Okay, so how do you think, how many instructions do we need to execute these following operations? So let's first talk about the first two. So what we are trying to push, first of all, try to understand the first one, push RA x1 onto the stack. So first of all, answer me what we are trying to push here. What does x1 hold? You have the reference sheet in front of you. What is it used for? x1 holds the return address. Now it doesn't matter right now why we are pushing it into the stack, but whenever we want to push it into the stack, how many instructions do we need to execute? 2 instructions. So first of all, while pushing, you have to reduce the value by 4, value of SP by 4, and then push the value RA into SP. Okay. Same is the case with this one. You can simply write it like this also. Same is the case with this one. When you have to pop, you have to first load the value from the top of the stack and then update the stack pointer to point to the another element being the top of this stack now. For this one, what do you think? How many total instructions do you need to execute? Let's try doing it here in the next slide. So if you have to push S1, S2 and S3. So we have seen once we require push, how many instructions do we need to execute? 2 instructions, updating the SP pointer and pushing the data with the help of SW. So for S1, S2 and S3, hold on, let them think. Yeah. Yep, you were saying 6 instructions. Ideally, we should be executing 6 instructions, but to avoid executing more instructions redundant, what we can do is we can perform the addition for the stack pointer all at once. Okay, so you have already know that whenever we push, we have to reduce the SP pointer by 4. If you push one value, you have to reduce it by 4. If you have to push 2 values, then you have to reduce the SP pointer by 8. Okay, and 3, you have to reduce the pointer by -12. Okay, why we are doing -4, -8, -12? Because every instruction is 4 bytes wide, a word wide. Okay, so if push instruction was here, suppose the SP was pointing to this location. So after pushing, after executing this instruction, it will be updated. Now its stack pointer will be pointing to this location. Okay, so initially it was 14, reduced by -4, -8 and -12. Now this is pointing to the next new stack pointer. Now you can push the values SW with the help of SW. What you are pushing S1 into 8 SP. Where do you think this value is going to be placed? Which address? So we are pushing our first value S1. Where do you think this is going to push the value? Where, at which address the value is going to be stored? Hmm? 9010. Yes. So why? Because SP is now pointing to this location, and we are performing a store operation as SP plus 8. SP plus 4 plus 8 is this. So S1 will be stored here. Okay. And then we can push similarly S2 here and S3 here. The S3 being added at the last, so that is why it is at the top of this stack. Okay. Any question here? And then what we need to do in the end, if you are loading the value, we have to suppose that after pushing, we are popping the elements out. Do you think this implementation is correct according to the principle of stacks? As same as we deduct -12 all at once, we can also add 12 in the end. instead of executing add statement one by one. It will only increase the number of instructions. So do you think this implementation, first of all, you can see you can read the value S1, S2 and S3 loaded and update SP all at the end to point to the new location. Is this implementation correct? If yes, why, and if not, why? Yeah?
No, because it's a stack, and you're supposed to take off S3, then S2, then S1.
So I could have written like S3 first, S2, and then S1. You could have written it like this also, but your comment is correct. That's a problem. I didn't get the first part that you were saying.
So for S1, it's specifically 2, or like it's, because it's 8. You're multiplying it by 8, right? So it's
Adding by 8. Yeah, the base address.
yeah. So when you flip it and you get the wrong address, you're not.
No, we can execute this instruction first, and this instruction at the end means S30SP can be executed first. It will just go at this location SP, which is now here, and it will execute this extract this element first, and then it can reach to SP plus 4 and can read S2, and in the end S1.
But I'm just saying, like in a stack, would they be flipped because it's.
It is currently flipped. So it is supposed to be reading S3 first, because this is pointing because the stack pointer is pointing to this location, the top of the stack, right? So again, your point is correct, and you are also correct that we should be retrieving the element from the top of the stack. Yes.
If we do all the reads and then set the SP pointer, can we potentially go like out of bounds of the stack if we don't increment the pointer after each read?
After each read, okay. Yeah, that is one genuine reason for that also. Yeah, it can go again potentially out of bound, but currently what is happening right now here is, according to the principle of a stack, we should always be reading from the top of this stack. So although this implementation is correct, it will retrieve all these 3 values and update the new stack pointer, but it should ideally be executing it like this. So if pop S1, S2 and S3, so first of all LW will help us read the value from the top of this stack. What will happen, what we need to do, what we should be doing now after reading a value from top of this stack, the stack pointer should be updated, right? So we should be writing this instruction which will move SP from here to here, okay? And now we can simply execute only from the top of this stack, and it will retrieve the value whatever placed at the top of this stack. And once after executing reading all the values, the final value of SP would be pointing to this location, which is again the same thing which we have done before, okay?